The Physical Earth, Lesson 3. This presentation will be about geology, physical processes of the Earth, and traditional and alternative energy sources. Geology is the study of the Earth's physical structure and its history. When we study geography, we also study geology. We look at the history of the physical structure of the Earth and the processes that shaped it. Components of the Earth. Components of the Earth are probably review for most of you. However, on your diagram on your follow-along sheet, I would like you to label the crust, the mantle, the outer core, and the inner core. Plate tectonics. This is the idea that the Earth's upper level of the mantle is divided into several plates, about 30 that are in constant motion. The plates are moving even right now. We don't feel the movement because it is very gradual and slow. When the plates slip and we feel sudden movement, we feel that in the form of an earthquake, and probably will be the only time that you actually feel the plates move. The contiguous United States sits atop the North American plate. As we review this PowerPoint, you will probably notice that there are YouTube video links. It is not necessary to view these videos at this portion of time. We will do this in class together. You are looking here at a map of the world and the Ring of Fire. And you can see that the Ring of Fire exists primarily in the Pacific Ocean. You can see that on the eastern part of the Ring of Fire. You'll see that it kind of grazes California and up the North American plate and then over toward Japan, and it continues down on the west side all the way down to the Antarctic plate. Now the Ring of Fire is a hot spot. We will view a video that'll kind of show us how islands are born in the Pacific that has to do with the Ring of Fire, and also how volcanoes and earthquakes are common along fault lines and also within this Ring of Fire. It's geologically a very active spot in the world. Now, the continental drift theory relates to plate tectonics. This idea is a theory, so geologists believe that this is probably what happened millions of years ago, that our current 7 continents were actually one giant continent called Pangaea. Over time, because of plate tectonics, Pangaea kind of broke apart from each other and the continents floated or drifted to their present locations. Now, with plate activity, we know that that creates many things. Earthquakes, volcanoes. If an earthquake is offshore, it will create a tsunami, which is a giant tidal wave. Now, Pangaea drifted apart to kind of float to their continent's 7 locations. Now, one way that geologists, try to prove this theory of continental drift is the idea that fossils from the same time period are identical, say in South America on the eastern portion, and then in Africa on the western portion, suggesting that these 2 continents were not separate but were joined as one at one particular time in history. Plate boundaries. Here we see divergent, convergent, and transform plate boundaries. At the plates where they meet, we call those plate boundaries. Divergent is where the plates kind of pull apart. Convergent is the opposite, where they push together. Now, if one plate pushes into another plate, you could have a mountain range, for example, form. But if one plate doesn't rise up with the other plate to form a mountain range, it could dive underneath and it would melt and continue the process over again. We will look at that in a video clip together in class. And then transform is when the plates actually glide or slide past one another. Now, weathering. This is a great picture of the Grand Canyon, and you could see the river at the bottom of the canyon. It's important to know with weathering that physical processes with the earth, some of them are due to weathering, rain, water, erosion, etc. Now, this river used to be situated at the top part, kind of lying on top, and over time the water, the force of the river has whittled away or cut away the earth to form this beautiful canyon. Now, if you think about what that means, it means the Grand Canyon is actually getting deeper because we still have in areas this water cutting through the earth. Now, for your follow-on guide, weathering is changes that occur as a result of weathering. It is a breakdown of rock at or near the Earth's surface into smaller and smaller pieces. So it's large rocks becoming smaller rocks, and smaller rocks and little tiny pebbles and sand pieces and dust. And that weathering process we see around the world. Mechanical and chemical are the two types of weathering. Mechanical is that rock is physically broken down and weakened at the surface. Probably two most common ways that we see this is frost wedging and seeds that might get into a crack of a rock and grow, and they start pushing that rock apart. Frost wedging is not seeds that get into the crack, but water. And when water freezes, it kind of pushes, it expands and pushes the rock apart. Chemical weathering is like an actual chemical makeup of the rock that it changes, forms with other rocks or combines and makes new chemical elements. So water and carbon dioxide can cause caves to form by dissolving rock, particularly with limestone. We see this a lot on the Yucatan Peninsula in Mexico. And then probably, a negative thing about human population is acid rain. And so the pollution that exists from cars and factories that makes its way up into the atmosphere again falls to the earth in the form of acid rain and can actually eat away rock. Now, once materials are weathered down, you think about dust and small rocks and little sand pebbles, that those materials actually move. And movement of weathered materials is called erosion. Erosion occurs by means of water, wind, or glaciers. And this is a really cool picture of a rock. And this rock has been eroded by, if you guessed wind, you are correct. So the wind blowing pieces around of little sand and so forth has weathered this beautiful rock to make it look this funky formation. And the same thing not only occurs with wind, but water and also glaciers. Now, I found this interesting picture. I thought it looked super yummy. It is a cake of the world, and it's pretty complicated. I'm not sure that I could go home and bake a cake like this. Now, if you cut it apart, you can see in the picture, which they've done, it looks like they've got three types of cake in there. They've got the white cake at the very center, which would symbolize the core, and maybe that would be the inner core. Then you see the yellow, and that might symbolize the outer core, and then the pink could be the mantle, and the frosting could actually be the crust. I think that cake looks super yummy, and so I am going to offer some extra credit. So if you choose not to do it, it does not hurt your grade. It's only for extra credit. If you would like to bring in something edible, now I don't expect you to bring in a cake this fancy, but if you had something that was this cool, by all means bring it in. The important thing is that it doesn't have to be this complex, but if you bring something in that is edible, that represents the components of the earth. So it would be the crust and the mantle and the inner core and the outer core. You may do so for extra credit next week on block day. That is the day that this lesson is due. In order to receive your extra credit, which will be 20 points, you must be able to logically explain how your item represents the physical structure of the earth. Now that is the stipulation on the extra credit. You've got to do the explanation in order to get the extra credit. Then afterwards, after everybody who's decided to bring in extra credit shares, then we eat all of the goodies that are brought in. Now, it doesn't have to be a cake. You could symbolize the structure of the internal earth in many different ways. It could be something like a dip or something that you would want to bring in with chips. That would work also. So again, this has been lesson 3, the physical earth, with a little bit of extra credit at the end, due in 1 week when this lesson follow-on guide is due as well. Good luck and have fun.